All right, second half of Lesson 6B in Algebra 2, Module 1, Unit 3. We're going to learn about something called the conjugates. Okay, so that's a big piece that we are going to use here with radicals that you have not learned yet. So, follow me on to the first slide. Okay, in the first slide, we got a binomial here. It says multiply and combine the terms and explain what you notice about the two different results. So, some of you guys with the box method, we'll set it up here. Bottom line, I got square root of 3 plus square root of 2 times square root of 3 plus square root of 2. And if I multiply, I get square root in this box right here, this first one, square root of 3 times square root of 3. So that's square root of 9, which is 3. Or you had a pair of buddies, didn't you? If I multiply this box right here, the second one on the top, on the right, square root of 2 times square root of 3, you cannot bust that up. It's just square root of 6. There are no buddies. The bottom one, same thing, square root of 6. And then the bottom right one is square root of 2 times square root of 2, of course, pair of buddies, which it turns out to be a 2. It's square root of 4, or known as 2. Put all the pieces together here. Once again, on our diagonals, you would have a 3 plus, on this diagonal here, you would have actually 2 sets of those square roots of 6. And no, they're not pair of buddies because you're not multiplying them. You're adding them, so make sure you don't combine them. I got 2 of those things. It's like saying, what's x plus x? 2 of those x's, okay? And then plus a 2. Finally, I can clean that whole thing up, and I can combine the 3 and the 2, and we call it 5 plus 2 radical 6. Okay? So that's what happens on this one. If you are a distributor type person, I'll do that other technique here. What's the square root of 3 times the square root of 3 when I do this one? It is called square root of 9, which is 3. Then I take the square root of 3 times minus radical 2. Notice the difference between the two problems is this has got a minus in it. And that will give me minus radical 6. 3 times 2 is 6. Then I take the square root of 2 times square root of 3, and that's a plus square root of 6. And finally, square root of 2 times a minus square root of 2 would be a minus square root of 4, which is minus 2. What happens in this one? Obviously, I've got a minus radical 6 and a plus radical 6, so it's that outside-inside combo. If you didn't notice, we got dots basically sitting here. In a sense, we got one thing times the other and plus and minus between them. So this actually comes out to be then a 3 minus 2, which is 1. And they do differ. So if you have the same thing times it and plus and minus, you know the outside, inside, middle part there is going to fall out, okay, that diagonal. On the other case, in the other one, it doubles. So that's something to notice here as far as it goes. All right. So let's move on here. If you take a look down below, you got important things. Two binomials that form this way are called conjugate radicals. Okay. When I do this one here, the conjugate of this one and minus that is actually turns out to be the opposite this way. Okay. So on something like this, if they ask for the conjugate, okay, of 2 minus radical 3, all you do is keep the same two terms, 2 and a 3, radical 3, but the opposite sign is actually called the conjugate. So that's where this comes from. This is what I would star. That's what you're going to need to know for this lesson. Right? So let's move on to another example. All right, so we'll see if you caught on to this. If you notice this, guys, aren't these conjugates? Same numbers, one's plus, though, and one's minus. So let's say you didn't catch that, and you go and you multiply. Well, same thing again. If I distribute here, square root of 5 times square root of 5 is square root of 25, which is 5. And if you go from there, we take the square root of 5 times the square root of minus 3, so that's going to be minus square root of 15. Inside is radical 3 times that, which is going to be a plus square root of 15. And the square root of 3 times the minus square root of 3 will be the minus square root of 9, which is minus 3. Once again, this thing with plus and minus, the middles drop out. So these two right here are going to drop out. So what are you left with? 5 minus 3, which in this case is 2. So that's going to be your answer as far as something like that. All right? And that's the way you can deal with these all the time. Take a look at the next one. See if you come up with something here yet. Same situation. We got conjugates, right? So if I do it, once again, 7 times 7, on that case is 49. We don't actually have a radical on them, so I'm not going to touch that. All right? Then you're going to get 7 times that, so it's minus 7 radical 2. Inside here is going to be plus 7 radical 2, so the same situation is going to happen there. And then minus the square root of 2 times square root of 2 is minus square root of 4, which is 2. Once again, these fall out. What am I left with? 49 minus 2, which in this case is 47, would be your answer. All right, stop for a second on the video. See if you can do the next one without actually doing this. What pattern are you noticing here so far? Now we've done 3 of these. Let's see if you've picked it out. Okay, so hopefully you caught on here. All you really have to do, because the outside and the inside, those first, is what I, from my old days of learning FOIL and that, but the middle terms there, that diagonal, are going to fall out every time when you got the same things, plus and minus the same things, okay? So all I have to really do is, on this case here, what is square root of 5 times square root of 5? Well, it's a pair of buddies 5, or square root of 25, it's 5. And what happens when I multiply 2 and a minus 2? It's going to be the minus sign. But what happens with 2 times 2? It's 4. So all you're doing is really squaring the 5 to get, squaring the radical 5 to get 5, so the square and the radical cancel. And I square the 2. What's 5 minus 4? It's equal to 1. Faster than doing it the other way. Up to you. Just catch on to that pattern. All right, moving on. So here's the big one we're going to deal with, okay? We have a simple, a rational expression. We got to go and basically reduce this fraction. But what makes this different than yesterday's lesson? Well, we got the plus minus in here, don't we? Somehow we got to deal with getting rid of this, and it's not so easy to do only because the minus sign. So I cannot just multiply by radical 3 in the top and the bottom. Because the problem is if you multiply by radical 3 in the bottom, you got to multiply both the 5 and the minus 2 radical. It'll take care of the one part, but then you're going to have a 5 radical 3 here. Cannot do that. So this is where the whole term conjugate comes in. So what we're going to do is we're going to take the square root of 3, that's in the top, and the bottom is the 5 minus 2 radical 3, and we're going to turn around and multiply by the conjugate. Well, what was the conjugate? The same numbers once again, right? But you need the opposite sign. So since this was a minus over here, we're going to put a plus here, 2 radical 3. And of course, if you multiply the bottom, we want to multiply it by the top. This way I'm not changing the problem. I'm really multiplying by the same thing over the same thing. So I'm multiplying by 1. I'm just making it look like a different fraction. So let's off and roll here. I got to take the square root of 3 times 5. So that's going to be give me 5 square roots of 3. I take the square root of 3 times this. Well, I'm going to get a 2 radical 3 times square root of 3. The 2 radical 3s are pairs of buddies, aren't they? Also known as square root of 9. So you can pull that out as a 3. If you want for a moment, I can write it out for you. We've got 2 times radical 3 times another radical 3. But that whole thing's going to clean up. So in the bottom here, I'm going to have a 5 radical 3. This is the top, sorry. I want to go on to the next case. Plus, this turns out to be a pair of buddies, so that's going to be a 3 times 2 is 6. So that's my new numerator, okay? In the bottom, we're getting used to doing conjugates, remember? Same fronts, same backs, one's plus, one's minus. All I have to do is square the front. So what's 5 squared? Okay, that's 25. And I got to square 2 radical 3. Now watch out for that. And it's going to be a minus. So it's going to be minus 2 radical 3 squared. So it's 2 radical 3 times another 2 radical 3. Because this is really, right here, is really 5 times 5. That's how I got the 25. So we got to do a little cleaning up here. Generally, we like the whole number first and the top. So I'm going to rewrite this as 6 plus that. That commutative property allows me to do that. And in the bottom here, I'm going to have a 25 minus. Now, what's 2 times 2? 4. Okay, keep that minus 4. And then I got a radical 3 times a radical 3. Pair of buddies. It's also square root of 9. Means it's times 3. So what's 4 times 3? 12. So my final step here will be 6 plus 5 radical 3 all over 13. And I cannot reduce that. That's where we're going. So that's what we're doing with conjugates. So we're going to do more of this in class tomorrow as well. So we're going to have some fun with this. The big thing is we multiplied by the conjugate here. That's how we did it on the top and the bottom. That gets rid of it. No more radical in the denominator. We can simplify that thing up. Okay? A little complicated. We'll get there though. Okay? As I always say, we'll get there. Have a good one. Enjoy your day. Mr. O says, peace out.